Aric.
All right, good morning, everybody. Hey, it's a pleasure to be here. Sorry about the weather this morning, but the Rockets won, so that's good. Astros lost, that's bad. So mixed bag this morning. I think he's going to turn on my lavalier here in a minute, so I'll stroll around the stage a little bit. So first of all, thank you for having me. I really appreciate this. My name is Aric Zurek. I'm the Director of Marketing and Technology for our aftermarket business of a company called Flowserve. So I'm going to talk a little bit about the company, but the most important thing I want to talk to you guys today about is true and real applications in industry. So a lot of our folks are the folks that go out into the field with our hard hats, steel-toed boots. We install the instrumentation, we connect all the network, and we bring up the systems live, and we allow our customers to get better reliability out of their flow control equipment. So a little bit about ourselves as a company. Maybe. There we go. Okay. I love the panel discussion, by the way. That was really good. And I think it's really interesting. I've been in the industry for almost 25 years, a lot of time in power. I've also spent the last 6 or 7 years in oil and gas, so I have a little bit of a mixed background in terms of what I see in the industry, in terms of investment around the startups that are engaging, around the cash that's flowing and the capital that's moving around the market to invest in this space. It's amazing, some of the companies coming out of Silicon Valley, out of Austin, out of Boston, and we've been talking and engaging with several of those folks over the last couple of years. A little bit about Flowserve. So we are a startup. We're about 212 years old, so it's a little bit of an older startup. But I feel like sometimes we're disrupting the industry and we're getting into new areas of development beyond traditional equipment. So originally, we are a manufacturer of pumps, seals, and valves. So we're deep into the customer's processes. We understand the equipment, we manufacture it, we service it, and now recently we're instrumenting and pulling information and data from that equipment. We've got a broad reach. We operate in about 55 countries. We've got 17,000 employees. We've got over 200 service centers around the world. So one of the value propositions and the way that we've been able to enable IoT in the industry is because we've got those capabilities within 2 or 3 hours of a customer site. So the customers are typically moving forward, but there's a little bit of anxiousness in the industry about how are you going to support me? How are you going to support the technology? What happens if I find an issue in the field? Who's going to help me? And so we can deploy those resources to do flow assessments. We can change out the pumps. We can upgrade the valves. We have all kinds of options in our toolkit. And by being able to offer that full service solution, that's allowing customers to be a little bit more confident to move forward down the path of IoT. We've got about 5 million assets in the field. Actually, that's probably a little bit of a low ball. We've got 2.4 million pumps in terms of an installed base. We've got over 5 million valves. So we are everywhere. We're in all different industries. We're about 40% oil and gas. So I like to say, I'll counter that last argument. I think innovation can come from the industry, but we do leverage the learnings that we find. We're in food and beverage. We're about 20% chemical and about 20% power. So we're pulling lessons learned from all the different industries. We're working with nuclear customers, we're working with major cookie manufacturers, wastewater treatment plants, and all the way to Australia in terms of mining. And I'll talk a little bit about those projects, how we stood up those customers in terms of pulling data into their network. It's very long range, speaking of wireless. Okay, a little bit about how we got here. So I feel extremely fortunate. There's a large team of people that have been working on this for a number of years. If anybody tells you that IoT, predictive analytics, machine learning is easy, I would be a skeptic. It's been a long journey. We've been working on our predictive analytics algorithms for over 10 years. We've been working on them for large ebulator pumps. That's sort of how we got into the business. Then we got into the more high energy pumps. And we've learned over the time, the last several years of how to deploy those analytics across the whole library. So of pump type models. If I want to go out into the industry and there's a certain model that we want to deliver a predictive analytics model for, or a certain asset, we can pull that out of our library and we can deliver that to the customer. So we've got the real world experience of building and servicing and operating these machines, and we're coupling that more recently with the predictive analytics and the wireless monitoring that allows us to marry the data with the asset. Couple of examples. So I wanted to kind of bring it into reality. I've heard a lot of discussion over the last 24 hours, some amazing intelligence in this room, a lot of I would say, people that are leaning forward into the technology, into the industry. We are out there, like I said, we're installing this equipment. The analytics that you all are developing, the technology that you are helping push forward, we're the ones that are taking it into the field, and I can tell you it's working quite well. So I'm extremely pleased with the deployments that we've done so far. This is just a sampling. So I mentioned a wireless monitoring customer. This is way out in Australia. This is a customer that moves alumina across a long distance, and they're way out in the middle of nowhere, right? They're about 4 hours from the nearest service site, and so they're highly independent and have to rely on their own capabilities and their own information. So they reached out to Flowserve and said, can you help us with a wireless monitoring solution? The answer is, of course. So we're working on technology. We've been doing it for years. We've been in this business about 10 years in terms of monitoring, and we're able to pull up that network in a couple of weeks, and now that customer has live data streaming from 375 assets. They want to expand to well over 1,000 assets, and that's just in one area of the plant. We've got one of our favorite customers. You might take a guess of who that is if you look carefully at the picture. So we're working with a company up in the northwest of the US. And this is, you would think that, hey, it's a food and beverage company, this is industrial, it's gonna be easy. But in fact, it's not. You get out to the site, the pumps and the valves and the seals, they're all operating in, I would say, smaller rooms. There's a lot of concrete, there's a lot of steel. Making cookies is not a simple business, and it's certainly not a clean business. So these are actually somewhat tough environments to work in. We're able to instrument that site. They're moving up to about 1,700 assets later this year. So another large wireless deployment. To do that, you've got to have the technology that works. You've got to have very effective and reliable sensors. You've got to have repeaters and receivers that can move and bounce that equipment around. And just like we're sitting here in this conference room, there's all kinds of interference, right? You've got steel structure, you've got posts, you've got concrete, all other kinds of radio signals bouncing around. And so you've got to have a device that can push that signal all the way across the plant and into a receiver so that you can reliably count on that data. Wired predictive analytics, I'm going to go more into detail on this in a minute. This is a customer that we've got up in the upper Midwest, large steel manufacturer, fantastic case study. These are pumps that are from 1961. So these are not new assets. These are assets that have been giving this customer fits for a number of years. They know they have flow imbalances when they change operating conditions. They're not sure what's happening. We went up and wired a couple of sensors up to that system. We created a new predictive analytics package for them, and now they detected within, I think it was 2 or 3 weeks of operation, one of my colleagues is in the front here, we detected cavitation. But it's not just cavitation at any old time. This is cavitation when they happen to run pump 1 and pump 5 at the same time, but not every day. It happens when they're in low flow conditions, but not every minute. So it's an interim dependency between how the pumps are operating and how they all flow into the common header. And so they couldn't diagnose exactly when this is happening. Now they're getting real-time data every second of every day, and they now are able to diagnose cavitation or low flow, rotor imbalance, bearing failures, all kinds. There's roughly 20 failure modes that we can detect, we can predict, and we can tell the customer when the asset has to come down. So we're able to look into the future with all this work that we're all doing as an organization and as an industry. We can now tell customers 2 or 3 weeks in advance of when they're going to have a problem. So that's amazing. I mean, that's a huge step change. We're working with a coal-fired power plant in Spain. So again, a different industry. We're in the power segment now. We're in a different part of the world. We're out in Spain. We're out off the coast. We're monitoring a couple of large boiler feed pumps. So these are critical assets that the customer cannot afford to have them go down. So it's worth it. Again, we're applying high energy predictive analytics in this case. So different pump, a little different solution. And then finally, we're working, I put this one up here because I'm a longtime nuclear guy. I started my career as a field service engineer, as a refuel floor technician, which was super fun, but I'm glad it's in the past. We were able to help this customer. They're setting up a monitoring center in their headquarters. I was actually just there 48 hours ago. So I was out in that monitoring center. They were showing me how they were taking all the data, and it's a group exercise here, right? This is not just Flowserve offering one solution. They're pulling information off their steam turbine condensate pumps. They're pulling information off their cooling fans. They're pulling their boiler information, all their critical system information from their PNIDs. They pull that into a centralized database. They're using our sensors and our equipment for the pumps. So we don't pretend to come out and say, hey, we can solve all these things. We'll work on your compressor, your gas turbines, your, whatever it is, whatever the plant has. We're going to focus on that flow control equipment where we have expertise. So if you're a startup or you're an equipment provider in the industry, I would strongly encourage you to get good at what you're good at. right? Get better at it. Understand the analytics, the engineering models, and the basis for your calculations and what you're predicting for the customer. And that provides credibility, right? So a little bit about the case study. I talked about this already. These are the 60-year-old pumps, which is amazing. They're still operating. They go through periodic maintenance cycles and that sort of thing. But we recently installed a couple sets of equipment on this. Like I said, within 2 weeks, we were able to detect something that they haven't been able to detect in 60 years. So an amazing solution. I'm extremely proud of the team. In fact, our team doesn't know it yet, but they won an engineering award from the company. So we're going to present that to the team here in a couple of weeks. What does this look like in the field? So again, trying to bring it to reality. This is not easy. I don't know if Ross is in the room. Ross was one of our project managers. He was here yesterday. He was out there with Ross and Aric and the folks that went and installed that instrumentation. So you've got to get into the customer's house. You've got to spend time walking the floor with them. You've got to understand where the equipment's located, what the environment looks like, how you're going to move the signal. You've got to have Ethernet connectivity in some cases, which means you're working with firewalls, you're working with internet security protocol. You've got to match the customer's requirements. So there's a lot of information that needs to be communicated. You've got to physically install the sensors. So you got to know what you're doing in terms of field applications and field installations. And you need to be able to provide backup power, because what if the site loses power? They're having a critical incident. You've got to put a UPS system in place. So there's all these things that you have to think through. The customer typically has to hire an electrical contractor to come out and do the wiring. So again, it's not easy. It's a collaboration. A lot of parties have to come together to make this a success. So my encouragement there is you've got a team in the industry. We don't provide all of the equipment, right? We can. We're a full stack provider, but in one instance for the software, for example, we partner with PTC. So we put everything on ThingWorks because we're not a huge software enterprise. Let's rely on people that have expertise in that, and they can provide that solution. So you can see some of the sensors. We put flow meters in there, pressure sensors, vibration meters. We put all that information in place so that we can pull that data into a centralized visualization engine. So if you're a customer, so we talked a little bit about the folks that are startups, we talked about equipment providers. On the customer side, what do we recommend, right? You cannot go out there and wire a full plant. It's just not possible. The cost of doing that either at a Shell or a Chevron or an Exelon or a Southern Company in those nuclear plants, that's very difficult. That's very costly, right? To run penetrations through concrete. You just don't want to get into that space if you can avoid it. So we recommend for balance of plant equipment, you're going to move to a wireless solution. So I already hinted a little bit at some of the wireless tricks. You've got to have very low frequency wireless systems. You've got to have a backhaul to be able to, let's say, update firmware when you need to, when you have updates in the field. You've got to have a very reliable signal that can punch through maybe 4 feet of concrete at a time. And so that's not an everyday off-the-shelf instrument. It's got to operate in an explosive-proof zone. So they call that Class 1 Div 1 or ATEX Zone 0. So again, you've got to get certifications. You got to be able to manufacture the equipment or partner with somebody to do that. And then again, you got to move all that data into a centralized library. So what do we use? We use OSI Pi. OSI Pi is a great database. So we've partnered with them to be able to store all that information and move it around and retrieve it. You can split the signal. And you've got to be able, we talked yesterday about the cloud. So customers are getting more and more comfortable with cloud analytics. So we push a lot of the data to the Flowserve cloud so we can take a look at cross-industry results, and we push it to the customer's cloud so they can visualize it from anywhere, right? Eventually into mobile, handheld devices, people in the field who can actually use that data. For critical systems, we recommend wired. So this is wired predictive analytics. We're working on a wireless package for that. But predictive analytics, which are first order engineering algorithms, first principle, those algorithms require typically a lot of data. We talked about that. So how do you move data around wirelessly? It's tricky, right? There's a limitation. So we tend to recommend more of a wired solution. You're also pulling, instead of a data packet every 15 minutes, it might be every few milliseconds, right? Or at least every second you're pulling information. That's a lot of information that needs to be digested by those algorithms to crank out a result. And it'll say, hey, my rotor's about to fail, or my rotor's gonna fail in 2 or 3 days. So this is a machine learning conference. So I wanna talk a little bit about machine learning. We also are highly interested in that space. So today we're deploying first principle engineering algorithms because I trust them, I rely on them. I was a degreed engineer as a mechanical engineer, love engineering. But as you guys have heard, there's a lot of new developments in the space around machine learning. What we're finding in our pilots where we've deployed machine learning is it's giving you good clustering information. It's giving you good early warning indicators. So I look at it almost like a military mindset of long-range radar. I've got my short-range radar that tells me, hey, in 2 days, this pump is going to fail. It's because there's wearing clearances that are inefficient, or because the rotor's out of balance, or because the bearings are having trouble, right? So that's very prescriptive, and it tells me exactly what to do. But it may only give me 2 or 3 days notice. And that's great. That's 100 times better than what we had in the past. But machine learning is interesting because it could tell you that same information we're finding like 6 to 8 weeks in advance. But machine learning is a little different. It doesn't tell you that it's the rotor or the bearing, or that there's low flow or loss of suction. It will tell you that I think something's wrong. So I'm not operating today like I was operating 6 weeks ago. And so that is very valuable information because it gives a customer much more time to plan. You can zero in on that asset, you can walk out to it, you can touch it, feel it, sense it, and see what's going on, and then that gives you an idea, okay, we need to turn up the information pipeline on this particular asset so we can pull that data more effectively. So the machine learning is really the long range, then you get to the first order or first principle engineering algorithms that gives you the detailed failure modes, and then you can take action. Okay, a little bit about the technology. I've kind of gone through this in some pieces. You do have to have that full stack. So whether you partner with folks, there's folks out in the industry that are fantastic at sensors. I'd say work with them. There's folks that are fantastic at networking equipment, right? Cisco's of the world, you can work with them. Folks are excellent in software. Folks are excellent in algorithms. Folks are excellent in hardware and service, okay? Flowserve does all of these things, but we have partnered in many cases for pieces of this value chain. We do happen to have an excellent portfolio of sensors, so we have both wired and wireless sensors, so we can deploy today in any application. And it's typically not just, you'll see out in industry some of our competitors or some other folks that are getting into this space, or maybe early on, they may offer one type of sensor. So they say, oh, I've got a vibration sensor, it's very effective, and maybe it's, Div 1 Class 2, or Class 1 Div 2, and it works and it's great, but it doesn't quite work for every application. Or maybe you need to pull multiple signals. You're not just pulling vibration, you're pulling pressure, temperature, flow. There's a whole myriad of information that you need. So as Flowserve, we decided to invest heavily in a full spectrum of sensors and solutions. So we go all the way from a tiny little, let's say, data logging device all the way up to full RTU that can pull tons of information. We put laptop servers on site so we can have an on-prem solution or a cloud-based solution. So we go the full spectrum. You've got to be able to move that data around effectively and efficiently. So you got to have good networking gear, and you have to have backups. One of the things we found is point-to-point communication tends to work a little better. When you start relying on other nodes in the network or a mesh network, it can get a little bit unreliable. Or if you're counting on batteries to maintain that power, it tends to overload one of those nodes in the network. So we tend to rely on more of a defense in depth, and so we can move that signal around a bunch of different ways. Cloud and data, it's true. I think we talked a little bit about over the last day or so about customer security requirements, how they're thinking about protecting the data, who shares the data. Today, most of the customers we work with do want to protect their own data. We can create derivative learnings off of that data, but in general, most of the data stays with the customer. You do, at least as a provider, so as a provider of IoT solutions, we like to be able to peek in and see how the network is providing, right? We don't need to necessarily see all the process data, but you need to, if you're in this game and you're in this business, you need to make sure your networks are reliable and they're operating, right? That's sort of the base rules of the game. If you can do that and you can provide a reliable network to your customers, they're going to be happy and their assets are going to be able to tell them what happens next. And then you've got to have a platform. So a little bit on the platform here. We've got a couple of different options, whether it's wireless or wired. This is a wired application. So this is, if you're a level 3 vibration analyst, you're probably going to pick apart my screen a little bit. But what we get into is third order octave spectrum for vibration folks. They can tell based on the pattern of those green bars on the left. If you could read the data, you would say, hey, that's a rotor failure incident, or that's a wear part issue, or it's a cavitation. This was actually, this is a real world example of that industrial customer. So based on the signals over here, we detected low flow and cavitation. We create a sense of alarms. So you can't just say, hey, here's the information, do what you must with it. We actually send a daily alert, and we'll send an immediate alarm to the customer. So we'll send them a notification and say, hey, you've got an issue on pump number 5, you need to go take a look at it. So we, not only do we provide the information, we have our own monitoring center. So we've got half a dozen people that are monitoring this information every day. And as we stand up all these customers and contracts, we're going to provide a little bit of overwatch, because it's in our best interest as a pump manufacturer to make sure those pumps are working, right? We want to make sure our assets are better than everybody else's and that they're up and running as they should be. You've got the ability to download all the information to Excel tables. We get a lot of reliability engineers, which tends to be our key customer. They say this is really fine and great, but I either want to push the data into my own system or I want to download it all and look at it offline. And so they've got the ability to do that, which is really fantastic. Okay, so I know we're short on time. There's not a lot of time. I'll take a few questions. I would say the IoT journey is upon us. I've never in my 20 plus years in the industry seen technology move faster in terms of development. I've never seen customers adopt it faster. 2 years ago, we were talking about little local data loggers that were, this size that you'd put on a pump and you'd walk by and maybe you'd use a USB and download the data and that was sufficient. They moved so fast from that to wireless monitoring on 1,000 pumps, and now they're up in the predictive analytics space and saying, hey, should we use machine learning? Can we use VR, AR? What else can we do? These are these customers that are these heavy-duty industrial, I would call them like heavy iron customers, and they are with us. They're in this journey in terms of moving their technology forward. They have to do it to be competitive, across the globe. They've got to reduce, their SG&A. They've got to figure out ways to be more reliable and keep their uptime up. And so we're here to help them do that. So we have 9 minutes for questions? Okay. All right. We can open it up to the audience too. We can be interactive. Do we have any solutions for valves in no particular order? So yes, we do. So in fact, we've got a new valve positioner. If you go online, there's a product called the Logix 3800. This is a brand new digital positioner that Flowserve released last year. So we're starting with that, right? We'll start with the new equipment. It's a little easier. It has onboard diagnostics for digital valve positioning. We're pulling that information in. In fact, I think it was December, that was the first time we were able to pull that into our IoT portal, and now we're creating the UI and the display interface to be able to look at valves. We can do everything for pumps, but now we're working on valves. So exciting space for us, and should be able to provide the customer more of a larger solution, right? Pumps, valves, seals, motors. Lots of time series data from IoT sensors in the field are bad. How do you improve and ensure quality of data from the field? This is a good answer, or good question. The answer I have to this is I just met with this big utility in the Southeast. They're pulling all that data in. They're asking questions they had questions on units, like what are the units of these, or how do you bucketize the FFT data, or do we have the right buckets, or within the 8 peaks that we provide on the wireless side. They're challenging the data, we're interpreting it, and so I would say the way that we do it is we partner with the customers. What I'm finding is when you do a deployment in the field, there's sort of this like shockwave that goes through that suddenly there's a bunch of issues, what they're seeing in the user interface doesn't match reality, and so you have to work out all those kinks until you change the units or the denominator, or maybe the equation's not working right for them, so there's a little bit of customization. And I'd say 6 to 8 weeks down the road, that system sort of levelizes and they understand what they're looking at. We've put it in a display format that makes sense for that customer. And so there's sort of a collaboration. So I would say you just have to work closely with the customers. That includes the operating team. So you can't just go into the ivory tower and say, hey, this is a corporate-wide initiative and roll out an IoT platform. We sit and we walk the site typically with the ops managers. So we'll sit there and these are the folks that do the maintenance every day, or their teams are doing the maintenance. So they come in with their hard hats and their orange jumpsuits and they'll tell you, believe me, they'll tell you when it's wrong. So you've got to get it right. Okay, what is the level of interoperability with other vendor equipment? Great question. With fast-paced innovations, what's the typical cycle or lead time for retrofit? Typically, so for wireless, I would say in terms of our build cycle, lead time is like 8 to 10 weeks. By the time a customer came to me and said, hey, I'm ready to go, it takes some time because we've got to build the system. We have to understand their operating conditions. How many data points are we going to collect? What are the different assets? So that's the lead time piece of it. Interoperability. On the wireless side, the sensors don't really care. You could put it on your air conditioner at the house. So it's pulling trend data in terms of vibration. It'll pull an FFT, 8-peak analysis. So we've got the ability to do that. So it doesn't matter on the vibration or pressure or temperature side. So we can pick any piece of equipment. On the predictive analytics, what I would say is we're finding that it actually works on Flowserve pumps and non-Flowserve pumps. I think that what we'll find is the further you go away from a Flowserve design, right? Pumps are pretty standard in terms of their configuration. So if it's a vertical suspended pump that's ours or somebody else's, they're generally going to behave the same, but not exactly. So what I'm expecting to see is, let's say 90% accuracy on the Flowserve pump. Maybe that drops down to 70% for another OEM's pump. That's still really great, right? Because remember, they're going from 0. So I'll take 0 to 70 any day. How do you compare your solutions to online vibration monitoring? I would say there's people in the industry that are specific to vibration, and if you're looking only at vibration, maybe you go with them, right? There's a couple of great companies out there. Bentley Nevada comes to mind, right? We use Bentley Nevada equipment on our original equipment that's shipped out of, let's say, Vernon, some of our big heavy-duty pumps. Because if you're doing something that's so specific that needs a very specific vibration system that costs tens of thousands of dollars, by all means, that's that solution, right? You want to go with a heavy-duty expert in the field. Our wireless devices are on the order of a couple $100s, right, per device. So it's really meant to be something that you put on the asset that tells you where to look next, right? So instead of sending somebody in a truck or into the field and they have to suit up, maybe go into a hazardous environment, for a couple $100, you can pull that data back into a central receiving point, and you can tell your technician, hey, go look at pump number 63A, right? Because you've now narrowed it down to that particular asset that it looks like there's trouble. So that's the value of that. If you've got a super critical asset, I would either wire it with, as an OEM, the original, let's say, spec instrumentation package, which we can use. We can take that data and put it into our predictive algorithms. Or if it's an aftermarket, meaning 10 years later you want to instrument it, we've got all this Flowserve instrumentation that we can drop in on that asset. Okay, how do you address comms in very remote locations? That's a good question. So I would say it's a mixed bag. We know there's a lot of issues. We tend to push wireless data around very low frequency. So it's an old military band that we use that's let's say 900 megahertz. That allows us to push a very small data packet over a very long distance. We're also investing heavily in LoRa technology. We think that's a good path of the future. That's very similar. That's like 868, which I think is pretty close to our technology. So that low band seems to be something that's able to move that data around pretty effectively. So that's how we're getting around that. We can use satellite. We've done that in the past, and we'll typically use cellular. So if we're moving data to the cloud, it's not so much data that we can't handle that. We push it cellularly back to the Flowserve servers. So far it's not an issue. Okay. I think that's it. Looks like our chairman's coming up. So thank you so much for the time. I really appreciate it. We'll be back in the back. Thank you. Have a good day.